let's discuss the Pythagorean theorem, which was introduced by Pythagoras, one of the great mathematicians. Now, in the Pythagorean theorem, it states that a squared plus b squared is equivalent to your c squared. Now, let's take note that here your a and b are actually considered as the legs of your triangle, and the c is the hypotenuse. So let's always remember that the Pythagorean theorem is applicable only when you are dealing with right triangles. So that's actually the limitation of your Pythagorean theorem. Now, let's always remember that A and B can be interchanged, but not the C. So the C here pertains to the hypotenuse. So how will we take note of that side? So it's always the side which is opposite your right angle. So we have here your right triangle, and this is the right angle. So that simply means that the C will be this side. This is the side opposite your right triangle or right angle. So in the same way that if you have this second triangle, then we could say that this is the side which is opposite this angle. And even if we have this, so again, this is your right angle, then we know that this is now the C. And this, you have to remember, is also the longest side of your right triangle, the hypotenuse. And then your A, sometimes we have this as our altitude, and of course the B as the base of the triangle. Okay, so it is stated here that A squared plus B squared is equal to C squared, and from here we can also derive the other formulas. Now if one of the legs are missing, you can now have a B squared is equal to C squared minus A squared, or A squared is equivalent to C squared minus B squared. So let's look into some problems where we could apply the Pythagorean theorem. Okay, so we have here three possible scenarios. Find the length of the unknown side in each of the following triangles. So we have here 24 cm. We can let that be the altitude, and B, which is now the base, as equivalent to 7. So it is obvious here that the one that is missing is actually the hypotenuse, which is now your C. So how are we going to solve for this side? So making use of your formula, which states that your C squared is equivalent to A squared plus B squared, all we have to do is to substitute now the value. So again, the C squared is equivalent to, we have here 24 being the altitude of your right triangle. So 24 raised to the second power. So we can just substitute there 24 squared plus the B, which is now equal to 7 in this case. So 7 raised to the second power. So when you are getting the product of 24 times 24, the answer that we will be getting there is 576. And adding now to the square of 7, which is equal to 49. So if we are going now to add the 576 and the 49, the answer that we are going to get there is 625. So this pertains to your C squared, but since the one that we have to look for is the value of C, there is a need for us to extract the square root of your C. So meaning you have to extract the square root of your C squared, and that has to be done also with 625. And we are going, if we are going to extract the square root of 625, the answer that we will be getting there is equal to 25. Okay, so we have now here your 25. So if these are all whole numbers, we can consider now 7, 24, and 25 as Pythagorean triples. Okay, so that is one pair of Pythagorean triples. Okay, so that's one. Now let's go to the second example. So here, let's locate the right angle. So the right angle is here. Okay, which means that we are given your 10 as the value of your C. Okay, which means that the thing that we are going to do now, okay, so we can have this as our altitude, okay, or the height of your triangle. And so therefore, we can now say that the base is the one missing. So therefore, from the formula, b squared is equal to, you can now have your c squared minus the a squared. Okay, so here we continue. Your c squared or your c is 10, so we simply have to square that. So 10 raised to the second power minus 8, 8 raised to the second power. And then that is 10 times 10, that is equal now to 100. And subtracting 100 and 8 squared is 64. So we have now 64. So you subtract, next is we have to subtract now 164, and the answer that we are getting is 36. But since these are all equal to your b squared, okay, we are now trying to find for the b, which means you have to subtract the square root of 36, and the answer that we are getting is again a whole number, which is 6. Okay, so we can add that to another list of our Pythagorean triples. So you have 6, 8, and 10. Okay, and for the third one, you have here, again, the first thing is you have to locate our right angle. So here is the right angle, which means the side opposite your right angle is the C. So C is equal to 9.42. So that simply means we can have this as the altitude of our right triangle. So therefore, the one that we are looking for is again the base. So again, we are following the formula. B squared is equivalent to C squared minus A squared. Therefore, we will now have B squared is equal to 9.42. So we have 9.42 raised to the second power minus 3.84 raised to the second power. Okay, so if you are given problems like this, it is expected also that your answer will be at least until the second power. So you have 9.42 squared is equivalent to 88. So we can now multiply. The meaning of 9.42 raised to the second power is multiplying 9.42 by itself. So the product that you will be getting there is 88.7364. Okay, and then we are going to subtract now. I will just write it here at the bottom. The square of your 3.84. So if you are going to raise that to the second power, the product that you will be getting is 14.7456. Now, there is a need for us to subtract this. So, we are going to rename that to 14. So, 14 minus 8 or minus 6, that is 8. And then that automatically becomes 5 minus 5 is 0. Again, there is a need for renaming. So, 13 minus 4 is 9. And of course, that becomes now 6. So there is again a need for us to rename this part. So 16 minus 7 is equal now to 9. And then 7 minus 4, that gives us an answer of 3. And of course, 8 minus 1 is equal to 7. Okay, we can check by adding 6 and 8, 14, 1. So you have a 6. 13, 1, 17, 1, 8, and then 8. Okay? So the next thing that we are going to do now is to extract the square root of this number. So I actually have one video here where you could find for the square root of numbers. So you can use that, or you can just calculate making use of your scientific calculator. So the answer that we are getting here is 8.60. Okay, so 8.60 followed by 17. So we will just drop the 0 there. Therefore, the B that we have here is equal to 8.6. So these are the answers that we can get for finding for the sides of your right triangle. Now, so as I have said earlier, it is only limited to right triangle. So what if there are some figures wherein they are involving other figures, like in this case? So as you notice, there is no right triangle that is involved. So there is a need for us to do some cutting, okay, in order for us to uh, find for a way to use our Pythagorean theorem. So as you notice, this is an irregular polygon, and then you are given different sides. But there is a certain way out for us to be able to answer this, and that is with the use of our Pythagorean theorem. Okay, so you will see there, you just make a cut so that you will be able to form now a right triangle. Okay, so from here, you know that the side that you have here is 5, and so this will also be equivalent to 5. Okay, that is from this point now, so I will just name that as our point E. So we know now that your BC is equivalent to your point ED, or to your segment ED. And so there is a certain side now here which we can possibly figure out, because we know that the sum of the whole thing here, which is now your segment AD, is 8. And since we are getting this portion, which is now 5, we can say that this is automatically equal to 3. And from there also, we know that this is a rectangle, so that is 4. Therefore, the side which is directly opposite it will also be equal to 4. Therefore, we already are given two sides, and it's already possible for us to find for the third side. Okay? And since we have here the right angle, we know that this pertains to the hypotenuse. So we will now use your x. So x squared will just be 3 squared plus your 4 squared. Okay, so we have now x squared is equal to 3 squared will give us an answer which is 9, and then 4 squared is equivalent to 16, and adding now your 9 and 16, the answer that you will get there is equal to 25. Now there is a need for us to extract the square root of both sides. Therefore, the answer that we will be getting here is equivalent to 5. Okay, so that is the measure for your side x, or the length of your segment AB. Okay, so let's have another example. Okay, here there are two missing measures already. Find the length of xy. So if you will remember, the 3, 4, and 5 are what are other set of Pythagorean triples. So 3, 4, so we can just let now your x to be equal to 5. Okay, since we just showed that solution. Now, after getting this, we can now use this one in order to figure out the measure of your side BC. So here, this is your right angle. Therefore, your C here, okay, or the segment AB pertains to your C, which is now 13 to the second power. So it's the altitude. We have the y here being the altitude of your triangle. So y, okay, we can now just have y is equal to, the longest side is 13, so we will just have that 13 raised to the second power, and that will be subtracted to the measure of your x here, which is 5. So 5 raised to the second power. And 13 squared is, 13 times 13 is 169, while 5 squared is 25. So we are now getting a difference of, subtracting now 169 and 25, the result that we will be getting here is 144. So again, this is y raised to the second power. Okay, but we are only looking for the measure of y, which means that we have to extract again the square root of 144, and that results to 12. Okay, so the answer that we are getting here is equal to 12. So x is equal to 5 there, and y is equal to 12. So there is another list of Pythagorean triple that we can derive from here: 5, 12, 13. So again, 5, 12, 13. Okay, and then let's have another one. Okay, this is a simple one wherein there is also a need for us to find for the length. Okay, so if you are going to look into this one, let's remember that we are forming now a certain rectangle here. Okay, so there is a need for us. We are given a measure here which is equal to 25. Now there is a measurement of y here, and then there is a need for us to find or figure out this side first, which is your x. So if you are going to do that, referring to this triangle alone, that simply means that you will be having, this is the opposite. Again, this is the triangle that we are trying to consider. So therefore, your x here, so x squared, is equal to, we have the hypotenuse, which is now 25. So 25 raised to the second power minus 7 raised to the second power. I guess I gave you this one as an example a while ago. So we have now 625, and that will be subtracted to 49. So if you are subtracting now 625 minus of 49, the answer that we are getting here is 576. So if you will remember, this one is one of the Pythagorean triples that we had a while ago, and the answer that we are getting here for x is equal to 24. Okay, so x is equal to 24. So it is advisable also that we memorize those Pythagorean triple for us to solve the problem or some problems easily. Now, why do we need to figure this out? Because the sum here, if you are going to check this out, the sum that we are given from here or from point B to C is 35. So this simply means that since you already have 24, so we are just getting this part, so that will now be equal to 24, and so we can say that this one will be subtracted to 24. So if that is 35 minus 24, we know now that this side will be equivalent to 11. Okay, and then this one is directly opposite this side. Therefore, we can say also that this will be equal to 5. Okay, and these are the two measures now that we need in order for us to figure out or to find for the value of y. So this is now the right triangle that we are considering, not this one. Okay, it is this small right triangle with an altitude of 5 and a base of 11. So this is the hypotenuse that we are looking for. So therefore, we will now have there y squared is equivalent to 5 squared plus your 11 squared. Okay, so squaring now 5, the answer that we will be getting is 25. And the 11 squared is 121. Okay, and adding 121 and 25, the answer that we will be getting is 146. So this is not a perfect square. So what are we going to do? We just have to extract the square root of 146, and that is equivalent to 12.08. So try to give your answer up to at least 2 decimal places. So this is now the value for your y. Again, your x is 24, while the measure of your y is 12.08. Okay, I will have another video for the other application of solving for or using the Pythagorean theorem.